where will you find resilience? REdeploy.
All right, so I'm another Google Slides person, so bear with me if this goes a little weird. Also, my clicker kind of has a mind of its own these days. So let me tell a quick story about the first time that I met John Allspaw in person. That looks real good up on the thing, doesn't it? So he comes over and he sits down and introduces himself, says hi, and I say hi. Very excited, and then he says, I've got a little bit of just unsolicited advice for you. And what I can only assume is a very Brooklyn way. He goes, and I'm just going to give this one to you. And so he says, 10 years from now, the situation you want to be in, you want to find yourself in a room filled with all of your heroes from the industry, where the only thing you're doing really is presenting to them on things they've already written and words that they've already said before. So that was like 4 or 5 months ago. And I think a lot of us here, right now, this is that moment for us. So I want to thank everyone here at REdeploy for making it such an awesome conference. This community is really special to me, and I'm so happy to be here. So I am here to talk about the meat of it. And I'm going to talk about how incident reviews and analysis in software has this tendency to rely on seemingly satisfying yet shallow and misleading oversimplifications, hiding from us that what we think is the meat of it is rather a bit of an empty bite. The other thing to point out here is I'm vegetarian, so clearly the expert on meat. This is pretty much the current state of digital online services these days. It's very cloudy. Thank you, Adrian Hornsby. So our software systems are intrinsically hazardous. They run in degraded mode. They're never entirely up. Systems operations are never trouble-free, and fixes to them introduce new kinds of failures. This is all in line with how complex systems fail, which has been referenced countlessly today. Software is no exception to this. Responders to incidents in software are riding that cloud of instability and working to keep our systems within the boundaries of tolerable performance, creating safety from moment to moment. In fact, they make it look easy, really easy. The problem is, the sky is cloudy with a chance of meatballs. So my name's Ryan Kitchens. I work on the core team at Netflix. We're focused on availability of the service, and we do a lot of work relevant to incidents. And yeah, that's really my last name. But I want to let all of you know that this talk does not feature any jokes about the company's chef. Following recent events, I decided to shelve those, like put them on ice for a little while. I know, tasteless joke. So this is the last food slide for a while, I promise. Resilience engineering warns us about boiling complex situations down to simple explanations. Software has built up a popular culture that I think is particularly vulnerable to this, where there is little patience for anything that's not easily attributed to measurable outcomes, like OKRs, for example. Right now, organizations who are operating at the edge of the envelope want to grow their capabilities, but they aren't sure where to invest in learning the messy details of how to outmaneuver the complexity penalties. I'm paraphrasing David Woods here if you didn't pick up on the word choice. So who can tell me what this is? Is anyone familiar with this? This is not a pipe. It is also not a painting here. It's a slide. It's not a slide, it's a projection of a slide. So what I want to get at is this concept called reification. to thingify something that is abstract and make it concrete and material. The point of reification is that hopefully it provides us with a useful illusion. It also works on different levels. Like a meteorologist probably wants a different description of the weather than a sailor does. But there are catches. Keep in mind, this can get us into trouble just as much as it can be useful. So I want to go through some examples of reification. Mother Nature is a pretty good example that everyone gets. Or an email, finding you well. Dumpster fires, bickering over whether that incident was really a Sev 1 or not. Every organization has at least one gnarly incident also that has kind of gone down in history. Like you've probably memorized the ticket number for it. Every time something similar pops up, everyone's like, is this another 1806? So the UML is not the code. What are microservices? Situational awareness. There are a multitude of things that make up whatever that is. Artificial intelligence. For that matter, what about IQ? Boiling down human intelligence to a number helps us with stuff like stack ranking employees and scoring them on yearly performance reviews, which is totally measurable and quantitative. Just think about the rigor that goes into navigating that evaluation area between 3.4 meets expectations and 3.5 above expectations. Those are some tough management conversations. Speaking of which, this is my manager. Meet Dave. This is his good side. One of the management challenges he's up against is that we have a whole lot of new hires on the team. Here's one of them. Something I really like about management at Netflix is a kind of near aversion to chasing these kind of evaluation metrics. We value freedom and responsibility. We don't infantilize people by boiling down human performance to a number. We ask experts what they need rather than telling them what to do. And we're hiring. Thanks, Dave. So, right, back to reification. That's a kind of oversimplification. I want to spend some time destigmatizing this word a little bit. I think it often sounds condescending and can be perceived in a way that's like propping up credentialism, and that's terrible. Oversimplification isn't inherently a bad thing. In fact, it's an inevitable consequence of learning. We all do this on some level, and sometimes we wouldn't get work done if we couldn't. Even expert understanding of anything that's at all complex is bound to be full of simplifications. The trick is recognizing when they're more harmful than useful. Has anyone heard of mechanistic reasoning? Right, so Johan Bergstrom calls this out in his investigation traps. We may look back on an incident thinking that it's just kind of the sum of its parts and that all we need to do to fix it is find the broken part. It may not seem common in software that we would run down a list of things that are all kind of working just to rule them out. But in fact, I think we do this all the time. Like, who has a dashboard with 100 different charts on it, and you're scrolling down the page going, okay, looks fine, looks fine, looks fine, excluding all the stuff to narrow down the scope of the problem. And then, oh, this wobbly line lines up with that wobbly line. There's the problem. Error also gets into this category. Through reification, we associate error with people. We ignore the dynamic interactions that people have with the system. We oversimplify the situations that people are up against routinely every day. And instead, we treat error as if it was a single thing. And voila, we found the problem. It was the human. With these kind of reductions, we boil it down to what looks like a choice between making an error or not making an error. The never-ending pursuit to eliminate that error is how we end up with tropes like automating away the humans. And ironically, as Lissam Bainbridge points out, efforts like this unintentionally make our systems more brittle because they hide the sources of resilience that make our systems actually work in spite of the complexity. So resilience engineering perspectives asks us to overcome this by looking at the potential for what's possible. This is really hard to do because it requires a diverse collective imagination. Will just got done talking about diversity in software and resilience engineering, and I think that really is a huge challenge that I want to echo that sentiment. Investing in this is really costly. You can't hurry it along, and it can deal with stuff that might happen so far down the road in the future that the benefits at the time are kind of uncertain. You've heard John Allspaw talk about how resilience is investing in it like without a justification to being able to do it monetarily. So few organizations right now invest enough resources to do this, and I think software struggles with anything that's hard to make measurable. But organizations who are seeking resilience at least they recognize the need to do something. So I want to present this quotation to you in dynamic worlds, or like in a world. There's no single well-formulated diagnosis of the situation. I think to expand this generally, I think this idea extends throughout incidents. There is never one true story. Rather, we make these provisional assessments based on partial and uncertain data, and those assessments are incrementally updated and revised as more information comes in. One of the consequences of failing to realize that is called fixation. And so in order to avoid the pitfalls of these reductive tendencies, Sidney Dekker says we have to get into the tunnel with the people. Understanding the context that people are working in allows us to capture local rationale. Context is what influences people's actions and thoughts. We want to know about the situations that people really faced at the time. I find this fascinating that knowledge accessed in one context may not be activated in another. The mere possession of knowledge does not guarantee that it will be used or activated when needed. Does anyone use like two cell phones for like work and personal? Right, so when you get paged on the work phone, something happens. This triggers a mode that kind of cues you into work. So an example outside of software of this is like when surgeons wash their hands before operations. Like, sure, it cleans their hands, but it also serves as this cue. So I want to switch modes for a second. Let's play a game. Using 5 words or less, utter a phrase that will elicit a great story from a software engineer with years of operational expertise. I'll start 100% tracing. So what does it look like on a microservice dependency graph when you enable 100% tracing? So TLDR, this happens. That's the meat of it, right? That's pretty much all anyone wants to hear, right? But how did we get here? So the impact starts at canary deployment, which starts annotating every request it gets with trace data, and this propagates downstream. Because canaries only handle a very small percentage of overall traffic, the performance impact kind of goes unnoticed, and then the canary terminates. But wait, there's more. The canary passes, so it gets promoted onto production, which starts annotating every request with trace data, every request. This propagates downstream. And downstream systems become overloaded, which leads to a retry storm, which clobbers the entire environment. And ironically, 100% tracing results in lowered observability because even when applications don't fall over, the data platform just throttles and drops it all anyway. So that happened. I also mapped out a timeline of this to show a little bit more of what's actually going on here. Right, let's just zoom straight to the customer impact window, because you only want to hear about the meat of it, right? It's that red kind of meat-colored part in the middle. So one of the things that comes to mind, it's inevitable really in an incident, kind of goes like this. Is it the network? I'm seeing a spike in TCP retrans. Like, it's got to be. Can we get the network folks online? Hey, is something weird happening on the network? But I'm not sure how to answer that question. Have you seen what happens on the internet? And when this dude's carrying the pager, like, you just don't have to ask questions like that. So how did we get out of this jam? Well, TLDR, we turned off tracing. Does anyone see it, though? I know it's a bit cluttered. There's a lot going on there. It's almost like there's never one singular... Oh, there it is. Config change. But what's going on with these 3 other config changes? Could this be fixation or people getting stuck there? Have you ever been staring down the terminal, about to press enter, and just not quite sure if it's going to make things better or worse? Surfacing those unproductive threads of activity reveals substantial data about our mental models. Zooming back out, let's talk about what's going on with those canaries. The yellow canary gets kicked off manually. The purple canary, however, is started by a schedule. So the way this works is it tries to start, but since the yellow canary is already running, the request to start the purple canary gets queued up behind it, and it just sort of waits. Rather than like just not running and being canceled, it sticks around in this queue waiting for its turn when the yellow canary finishes. So the yellow canary makes its way to the end of the pipeline, and it passes with a 100% score, and then immediately the purple canary kicks off. In the meantime, this teal pipeline, an accidental commit was merged. This commit changed the configuration to enable 100% tracing. This was intended for local testing purposes on someone's laptop. They didn't realize it got committed. Does anyone else have some bones to pick with the ergonomics of Git? I recommend reading Behind Human Error through that lens. It is fantastic. So the purple canary starts pulling in the latest tag, which has this accidental commit, and begins taking traffic, which starts annotating every request with trace data, and this propagates downstream. So it's at this point where the infrastructure starts to throw alerts, but eventually the canary passes anyway, it deploys the prod, and well, you get the gist of it, right? An oversimplification to call out here is better worker. We assume the mistake is the problem. Hire the top performers, and they'll make less mistakes, and we'll be good. Instead, it's the mistakes which expose deeper systemic flaws. The person didn't fail, the system failed the person. The broader argument to make here is there are no mistakes. Like, human error doesn't really exist. There's only variability of performance. So it's our task to avoid fixating on the outcome and instead attempt to glean insight from these glimpses into the context of how work is actually accomplished. This whole stuff about canaries being capable of getting queued up was something we only discovered through interviewing people. This was not a commonly held belief amongst many engineers prior to this incident. One thing we're able to generalize out of this analysis is how to find when engineers aren't receiving enough feedback to understand when the system is making changes to their applications, and what the implications of that are to observability. Okay, so the next incident, I call this one change your things. This is one I've spoken about before, where a website got overwhelmed by a burst of traffic. So here we have the internet traffic coming into the gateway to our mobile and website environments. The website also contains this like billing and sign-up workflow. So a config change, again, was made to this IP block application, which wiped out all the blocking rules. And this empty list was uploaded to the gateway and took effect instantaneously, globally, all at once. Typically, this wouldn't be terrible because we expect the IP block application to sort of redetect the malicious traffic as it comes through, but unfortunately, that didn't happen, and that malicious traffic kept coming through and overwhelmed the website. So strangely, even though the front door was open, the mobile stack was not impacted by this. For the website, emergency capacity was added right away. And when auto-scaling kicked in, the system was kind of able to recover and catch up on its own to serve that increased rate of traffic. But we didn't know why the malicious traffic wasn't starting to be picked up and blocked again. The block list remained empty the whole time. Then we found a bug in our IP block application. The malicious traffic was exploiting the way the rules engine was parsing a particular cookie based on like special characters, commas, semicolons, kind of thing. So this effectively bypassed all the detection mechanisms. So we fix it up, and the gateway starts detecting the bad traffic again, and all is fine. So what's the meat of it here? We tend to think it's that window around customer impact and fixing that bug, but digging in just a little bit, we start to find that there really isn't a whole lot of meat here in comparison to the other stuff that we unearth as we start to dig. Like, what was the motivation for that config change? It turns out we were blocking legitimate customers from ISP, internet service providers, who have large NAT pools. So a whole bunch of customers were behind a single IP address, and that looked malicious to our IP block system. So customer service requested that our team make this change. So the change got entered into the Safer Changes tool. But wait, that one's deprecated. The new one is called Changer Things. The new tool rolls out things progressively rather than globally. So you might think, well, if the engineer had just used the right tool, none of this would have happened. So now we can move forward knowing that and just kind of brush off what happened here. Like, take the move fast and break things mentality. All we have to do is officially decommission the old tool and we'll be fine. But there was more going on here than just the config change. It was also holiday time, which meant gift cards. It also means peak holiday traffic. A record-breaking amount of traffic was coming through, and this was made even worse when the block rules were wiped. And to top it off, we discovered a strange loop from the gift card redemption workflow and the sign-up process back into the web app. So we had this like wickedly impossible retry logic while the web app was already under capacity. So the web app actually stopped reporting metrics while it was under load, so the auto-scaling, which depends on those metrics, took way longer than expected. This problem was actually kind of a good thing in this context, because that retry logic can make the web app keep scaling up and wasting money until it hits insufficient capacity errors from the cloud provider. I could go on, but suffice it to say, this is definitely one of the stranger incidents I've seen. So I can hope you can start to see that the meaty part of it is really in all the messy details that aren't directly connected to the IP block rules change that triggered the customer impact. It's all the stuff we learned about people working to overcome the incident. And if we hadn't found those things, they would continue to be present across multiple incidents. So we have to get past this notion of like static, linear, causal explanations of incidents to even really start getting at the meat of it. So have you ever seen a spreadsheet take down a database in prod? So when this was first brought to people's attention, the scope of the incident was roughly this. This is what we thought all the services involved were. There's a suite of services that calls into a GraphQL layer, and behind it are some APIs fronting a couple databases. Well, one database ran out of disk space, and it all kind of blew up. Pretty clear what the critical path is here. The response here was to add more disk space, and then everything recovered. Each of the service teams involved here kind of ran with their own separate investigations, which were all kind of locally scoped in perspective. So it took about a week until their stories started converging at the database that fell over. And then my team was pulled in to build a more holistic picture. Our understanding of the ecosystem grew and grew. So kind of soup to nuts, we have two paths laid out here. One path into the GraphQL environment and another one outside of it where we're directly querying a database. In the context of this incident, one of the goals was to generate a spreadsheet that contained consistent naming conventions for each of the columns. Finding out this context and the motivation behind the changes moved the timeline back 3 months before the day that the database had an outage. So in trying to make that spreadsheet consistent, the request path was switched from this database query to querying the GraphQL layer. What we didn't know about was a latent bug in the application that generated those spreadsheets. So in the switch over from the SQL path to the GraphQL path, a caching layer was lost. We ended up calling the GraphQL endpoints about 500 times more than intended, which fanned out to downstream services. That increased the request rate, and that brought with it excessive logging on the database. And that's how it ended up eating disk faster than faster. So new solutions come with new hazards. Anytime we're trying to fix up something, it's a useful exercise to try to figure out what kind of new failure modes we might now be introducing. So I just want to reiterate that even in seemingly simple cases of like the database ran out of disk space, there's really a whole lot of things going on. Things are changing dynamically that kind of create the condition for events to conspire into these surprises and unwanted outcomes. So now I'd like to remind us about a theme that came up at last year's REdeploy. Where are all the people in this diagram? I've been hiding that from you in all of these maps. Like, where's the beef? Looking back at our first incident, if we try to fit it to that above the line, below the line model, this you can find in the Stella Report, you see the meat of it isn't about the individual parts or the outcomes. It's about the interactions and the relationships between those parts. Each of these lines should really be annotated with what people were seeing and interpreting, discussing, and what they were doing about it. How did people get stuck? To see this sort of thing done properly, you have to check out Marissa Grayson's thesis. She'll be speaking here tomorrow, so there's a bit of homework for you all. So if I haven't convinced you yet to change your mind on what you think the meat of it really is, maybe let me approach it from this angle. Forget about blameless postmortems. Let's talk about meatless. My wife told me this was beyond lame. So I've highlighted here a bunch of intro topics to resilience engineering. Now, what do we do about all of this? I want to leave you with this advice from Todd Conklin and David Woods. The Woods' 3 Eyes comes from a chat he had with the Columbia disaster with NASA, I believe. And Conklin's 3 questions are in his latest book. This advice gets to the point of creating an organization where it's safe to continually question all of the things we think are undeniably true. Simply saying you're a learning organization does not make you one. Learning is hard. So to quote Todd Conklin, learning takes effort, deliberate resourcing, and courage. And to quote David Woods, we live in an adaptive universe, and we can no longer hide behind static, linear simplifications. The dangers of oversimplification are real. I want to echo a point that Todd Conklin made recently. So at the start of this talk, I brought up a tasteless joke about ice. I hope you can see that separating children from their parents as a means of deterrence of immigration is one of these oversimplifications. I'm continually reminded of the dangers of this kind of thinking when I see CTOs and VCs who are investing in software talking about getting to the root cause of the opioid crisis or using the 5 whys to diagnose the lack of diversity in software. The bottom line is, as software continues to creep into other fields and become dependent on in increasingly critical ways, my worry is that if we don't do this work and create spaces like REdeploy, then other industries are going to end up becoming a lot more like us than we will like them. Thank you.